It's Friday. I am excited. I know that you are. I am not here, but kind of here. You might see me wandering through the school a little bit today, but as far as being in the classroom, I am not. So I apologize for that. I hope that you have an awesome day today. We're going to get right into yesterday's homework assignment. So if you would, get out the appreciation and depreciation worksheet. I can't talk. And we're going to start going through all 6 of these problems. And then during this time, the substitute will pass out your note sheet and homework for tonight. I'll tell you what problems I want you to do once we get finished with the notes, but we're going to move straight from this homework into our note sheet. Shouldn't be too hard of a day for you, but of course I'll let you decide that as we go. All right, so let's jump right in. Each day, Juan deposits, again, here it is, twice as much. Again, for what we talked about yesterday, if you're depositing twice as much, that's doubling. We are using the doubling formula. So if you need to go back and look at your notes, you can, but we're using the formula for doubling. It says he is doing twice as much money as he did the day before, and his initial deposit is $4. That is his P. That's his principal amount. That's his initial amount. So write the equation to model the deposit Y. So Y equals P, that's the principal, 4, times 2, and it says on day X, so that's my time, so X is my exponent. So Y equals 4 times 2 to the X. Again, we talked about one just like this yesterday, so that should be pretty easy. And then, of course, the second one says, well, how much should he deposit on day 7? Well, I'm going to go to my calculator, and I'm going to type in 4, open parentheses, 2, close parentheses, raised to the 7th power, and here you see the answer is 512. If you got 512, you got that one right. Again, y'all had quite a bit of time yesterday to work on this, so I'd say you probably already had that one done. Look at number 2. A bacteria culture contains 400 bacteria. The number of bacteria, there it is. It triples. It triples. We're using our tripling formula. So how many will it be after 5 hours? So obviously this one doesn't ask me to write an equation. We're just going to go straight into solving. So here we go. A equals P. That's my initial amount, 400, times 3, because it's the tripling formula, raised to the 5th power. That's how many hours we're talking about specifically. That's my T, that's my time, hours, 5 hours. So if I go type that in, 400, open parentheses, 3, close parentheses to the 5th power, there will be 97,200 bacteria. So hopefully you got that one right. Let's keep on moving. Excuse me. Number 3, a painting valued at $70,000, that's my P, that's my initial value, appreciates. So here they just go straight into it. They tell me the word appreciate. We talked about that yesterday. It means my money is growing. And how's it growing? It's growing at a rate of 7.5%. So remember yesterday we said, hey, let's go ahead and let's change that to a decimal. So let's move that decimal 2 to the left, and that's exactly what you end up with. Look, it was here, and I went 1, 2. That's where it ended up, 0.075. That's my R. So it says create an equation. So we're actually not even solving this. We're writing an equation on what would represent the value V. Okay, so V equals, and then I look at my appreciation formula. That's P, principal, 70,000 times 1 plus, because it is appreciation, 0.075 raised to the T power. Now, that's the equation. You know what I'm going to do? I'm going to move it over here. That little line in the T didn't come with me. I'm going to move it over here because when I just write the equation, I personally like to simplify that value that is inside my parentheses. So I would go 1 plus 0.075, and I would change that to 1.075. If I was just solving and I was just typing this into my calculator to come up with an answer, I probably wouldn't waste my time doing that. But it wants me to write an equation. And generally when we write equations, we simplify it as far as we can. And that's as far as you can simplify this, okay? There's no other value to plug in. That's where we stop. Okay, number 4. A van rental company purchases vans costing $22,000 each. Again, that is definitely going to be my P, my principal amount. The value of the van depreciates by 17% annually. So right off the bat, I'm going to change that to 0.17. Again, look, if I have a decimal here, right here, I go 1, 2 to the left, and that's how it ended up in that spot. Now, it uses the word depreciates, so it tells me everything I need to know. I can now write a function that represents that value of the van after t years. So here it is. A equals P, 22,000, open parenthesis, 1 minus 0.17 raised to the t years. Again, since I'm writing an equation, I'm going to go ahead and simplify that. 1 minus 0.17 is 0.83 raised to the t. So if you want to think about it like we talked yesterday, that's basically saying that every year it's going to be worth 83% of what it was the previous year. 83%. Remember, it's 100% minus 17%. That's how that value makes sense to my brain and lets me understand how it's depreciating. It's not worth the same amount. It's worth 17% less. So to answer the question, we simply go 22,000 times 0.83, and we want to know how many or how much it's worth after 4 years, so raised to the 4th power. So that answer, if you type it in your calculator, I got $10,440.83. If you got something different than that, I mean, there's a chance I typed it in wrong. I was going pretty fast. So double check me if I'm wrong and see if that is the value. Okay, number 5. Amanda is a teacher. She was earning $32,500 per year when the school system agreed to give an annual raise of 2.6%. There it is. They didn't use any fancy word. They didn't say increase. They didn't say decrease. They didn't say appreciate. They didn't say depreciate. They used the word raise. And raise means your money is doing what? Well, it's going up. So we know that this is going to be appreciation. 2.6%. Again, I go ahead and take the time to change it. So I take that decimal that's right here where my cursor is, and it goes 1, 2 to the left. So 0.026. And it wants me to find Amanda's salary 7 years after the raise was instituted. So here it is. We're going to take, to find that amount, we're going to take the original amount, $32,500, which I need to update these. That is not quite what beginning teachers make now. But anyhow, $32,500. It's a raise, so we add 0.026. And then we raise that to the t power, which is 7. So I talked about this a second ago. In this case, I wouldn't simplify this. Since I have all the values, I would just go straight to my calculator and plug it in. And if you do that, you get $38,896.89. So that was all the problems that you're supposed to do on the front. But I did ask you to flip over to the back and do number 8. And I said yesterday that maybe this one would be a little bit harder, but hopefully not, considering what we've talked about. It says the change in population of fruit flies can be modeled by this equation. So I hope that you guys recall, when I look at this equation and I understand what's going on, I should remember that it's P, and it's either 1, which I see right here, see that, 1? And it's either plus or it's minus an R. raised to the 10th or the t power. So think about this, guys. To get from one, either adding or subtracting r, how do I get to 1.45? Well, clearly I'm adding. So I'm doing 1 plus whatever that r is. So hopefully you guys can kind of look at it from this perspective. If r is 0.45, we're going the opposite direction, right? How did I go from a decimal or from a percent to a decimal? Well, I moved it 2 to the left. So how do I go reverse direction? Well, I move it 2 to the right. So this is 45%. So let's answer the questions it asked. Is this growing or decaying? Well, it's definitely growing. It's definitely appreciation. It's definitely growth. What is the rate that it's growing as a percent? Well, I showed you that too. It's definitely 45%. And what was the initial amount? Well, that's your p-value. That's your 4. So maybe that was a little harder for some, probably not necessarily for others, but you now have it. There shouldn't be really anything here that was difficult because it was all so similar to what we did yesterday in class. So hopefully you got all that written down. And again, with me not being here, if you were here today, you're going to get 100. If you're not here today, you'll have to make this up, maybe by watching the video. But anyways, we'll talk about that on Monday when you return. So we're going to jump back into a new lesson, and that lesson is compound interest. Okay, compound interest. Compound interest is when you have money that is growing, but it's growing based on being compounded a different amount of times per year. So it's going to change based on how many times per year am I compounding this. Okay, how often are we getting to add this interest to this money? That's what we mean. So here are the options that we're going to discuss. Annually means that it's compounded only one time a year. Now, if it's compounded only one time a year, it's just going to be like normal appreciation. It's just dividing by 1, which we'll talk about in just a second. Semi-annually means 2 times per year. Quarterly means 4 times per year. Monthly means 12. Weekly means 52. And daily means 365. Now, if you don't know these dates, if you don't know these numbers, if you don't know that there's 4 quarters in a year, there's 12 months in a year, there's 52 weeks in a year, there's 365 days in a year, I would recommend that you memorize these, okay? These are things that you need to know what the numbers are when you see these words. But also, when you see these words attached to compounded, so it's going to say, hey, your money is compounded, and it's going to say one of these words. That is the dead giveaway that you are using compound interest. Now, I want you to notice, here is the equation for compound interest. And I want to show you something real quick. The formula for regular appreciation that we talked about yesterday is P times 1 plus R raised to the T power. Now, listen, this was no problem for you. Do you see the difference? Here, you're dividing by N, so you're taking that R and you're dividing by N, but then you're going to multiply T in this exponent spot by that same value of N. So guys, literally whatever goes here has to go there. Do you see this? And then you're going to utilize your calculator. Now, if you guys recall, a second ago I told you that if it was annually, it's the same thing as appreciation. Because think about this. If it's annually, isn't it 1? And if I divided R by 1, isn't it just R? And if I multiplied T by 1, isn't it just T? So compounded annually is the same thing as appreciation. Please commit that to memory. as far as your brain goes. Everything else, whether it's semi-annually, quarterly, monthly, weekly, or daily, you're going to get a little better outcome because your money is being compounded more often every year. So it's better, okay? It's better. So this is what we call compound interest. You don't have to memorize it, okay? It's going to be something that is given to you. So that's a good thing. But I want to show you something. If you come over here and look, and you look at a very simple computation, and as you see how many times money or whatever you're dealing with, the more times it gets compounded every year, I want you to notice what it starts moving towards. Does that look familiar? 2.718282462 Does that look familiar? I hope it does. The more something gets compounded, the closer it moves to that mathematical constant we talked about called E, Euler's number. The natural base that we've talked about. So, when we talk about something being compounded constantly, or we actually use the word compounded continuously, because things being compounded more and more and more and more moves closer to a base of E, we use an equation that I talked about the other day that we call continuously compounded interest. And that is A equals P, your principal, times E, your Euler's number, 2.71828, raised to the RT power. So, PERT, if you want to memorize it like that. So there are two formulas we're talking about today, and it's a dead giveaway how we know which one we're using. If we're using compound interest, they're going to say it's compounded one of these words. Semi-annually. It's compounded quarterly. It's compounded monthly. It's compounded, you get it. If it's continuously compounded, they're going to literally use the word continuously compounded. It's not a secret. It's not a challenge to see and find. It's very, very straightforward. So that is the hurdle we have to cross today. So let's start looking at some examples. Wendy deposits $550 into a savings account. You already know what that is. That's your P, right? That's your initial value. The account pays an interest rate of 4.5%. Again, let's keep doing what we've been doing. That's 0.045, right? We move that decimal 1, 2 to the left. And then here's the key. Look what it says. It's compounded how? Quarterly. We know we're using the compound interest formula, which is P times 1 plus R over N raised to the NT. Now, I know you have it above you. I just want you to see. That's how I immediately know all the values I have to plug things into. So here we go. It says, write a function that gives the amount of money in dollars, W of T. So instead of A, we're going to use W of T. And that equals, after 10 T years. So my principal amount, again, was $550 times 1 plus, my R we already discussed is 0.045 divided by N. Now remember, what did we say N is? It's the word quarterly. Quarterly is always 4. N is 4. So we put 4 here and we put 4 here times T. Now, I like to clean this up when it asks me to write an equation, just like I did yesterday. So I'm going to write 550, but I'm going to go to my calculator and type in this value that's underneath. Okay? I'm not going to do this with every problem because, let's just be honest, we don't have time for that. But I'm going to go in here and I'm going to type in 1 plus alpha y equals number 1 0.045 over 4. And I'm going to let it simplify that for me. Now look, does this look like it goes on and on and on? Or does it look like it terminates? Well, it definitely looks like it terminates. So use the whole value. It's so important that we get the right answer. We're not going to round to 2 decimals here when it's just 3 more numbers. Do you understand that? Please make sure you don't round when you don't need to. So I'm going to use 1.01125 when I rewrite this equation. So here it is. It is 1.01125 raised to the 4t. There's my equation. Okay, let me highlight it so you can see it really nice. There's my equation. I don't know if it actually helps or hurts. Now, it wants me to find the value after 10 years. Well, no problem. I got that. I type into my calculator 550, open parenthesis, 1.01125 raised to the 4 times 10 power. Again, remember, don't forget, we already took care of this in here, but we have to multiply that t by 4. So I'm going to go to my calculator one more time. It used to be so much better going to my calculator. So we're going to type in 550, open parenthesis, 1.01125, close that parenthesis, raised to the 4 times 10 power. So there it is. It's going to be $860, and remember, it's money, so we're going to round to change, so that 7 rounds up to 1. So it's $860.41. $860.41. And that's it. That's all there is to that problem. I don't think it's overly difficult. I know that I teach it, and it's not supposed to be overly difficult, but I think you guys can do this. Okay, look at this one. Couple makes an investment of $1,800. That's P. Into an account that earns 8%. Okay, that's 0.08, right? Look, I moved that decimal 1, 2 to the left. 0.08. And it's compounded how? Monthly. Monthly is 12. And it just asked me to find out, well, how much is she going to have in 15 years? So I'm literally going to go and type in A equals, well, actually, you can't type that into your calculator. You're going to go type in 1,800, that's your P, times 1 plus R is 0.08 over N, which is monthly, 12. Close that parenthesis and raise it to the N, 12, times T, 15th power. So I'm going to go to my calculator. Again, I don't want to keep doing this every time, but at least the first couple of times, I'm going to type in 1,800. I'm not going to worry about simplifying that inside. It's just not needed here. 0.08, and that is over 12. Then we close that parenthesis out and raise it to the 12 times 15 power. Push enter, and my number is 5952 point, and then that 8 rounds that to a 6, 46. So my answer is, it's money, $5,952.46, compounded monthly. It's not too bad, right? You feel confident about this, I hope. Let's look at another example. Sarah deposits $2,000 into an account that pays 2.7%. Now, again, remember, that's 0.027. But look what it says. It's compounded how? Continuously. This is your A equals P e to the RT, which is quite simple. So A, write a function s of t. So instead of A, we're going to use s of t. And it equals the amount we start with, P, that's 2,000. Remember, E is E, right? That's your base E. That's your Euler number, 2.78128, right? Raised to the R, that's 0.027t, because we don't know t yet. This is just the equation. Now, fortunately for us, is there anything I can simplify here? Nope, that's it. So, lastly, how do I find how much money she has in after 30 years? You type it in. So 2,000 times E. I always kind of open a parenthesis for my E. In my calculator, I don't really have to do that. So it's just a habit, I guess. 0.027 times 30. So when I go to this calculator, I'm going to go like this, okay? I want you to see it. I'm going to go in here and I'm going to type in 2,000. I'm going to use the second ln because it already has the exponent there. And then I put my 0.027 times the time, which we said, again, was 30. If I push equals, there's my answer. It's 4495.8. That 5 rounds that up to a 2, so 8.2. So I get to write $4,495.82. And that's it. That is 2 compound interest formula problems. That's 1 compounded continuous problem. And then we have a couple of extra where the question's asked a little more different as far as the way we're supposed to solve. See, they give us the equation. So first of all, we can rule out that this is PERT, right? It's not PE to the RT. That's not PE to the RT. But this one is, right? That's not PE to the RT. So these must all, if they have a value here with the T, they do have to be compound interest. So that's compound interest. And think about it. If that N is 4, how many times is it compounded? 4, which we would say is quarterly. We'll talk about the rest of it in a minute. Let's go through all these that same way. This one has a 12. Y'all see that? That's N. If there's any number next to T, that's your N. So this is saying it's done 12 times a year, which is monthly. Of course, this one, it says how many times? Well, it's continuous, right? Because it's E, continuously compounded. This one is a 1, so you would say it's annually. I hope that makes sense. Look, there's nothing next to it. It's understood a 1, so it's annual. Okay, so the next question's, the first question is actually really simple. What's the p-value? What's the initial deposit? Well, this one, it's 200. This one, it was 1,000. This one, it was 400. And this one, forgot my dollar sign. And this one was 6,500. Now, the hardest question is the last one, rate. How do I know what the rate is? So here's my encouragement to you. Remember, these are compound interest, right? So this one was 1 plus R over what? What was the N value? Do we know it? Well, of course we do. Remember, whatever this value is had to be the N value here. So here's the point I'm making. This value right here, please pay attention here. This is the hardest thing I'm showing you today. This value right here was derived by doing 1 plus R over 4. So 1 plus R over 4 equals 1.0125. You understand? So how would I solve that now? Well, you know how to solve equations. Don't we need to get R alone? Well, I can't move the 4 yet because this 1 is over here. So don't I first need to subtract 1? So I'll be left with R divided by 4 equals 1.0125 minus 1 is 0.0125. So how do I finally get R alone? Well, what's the opposite of dividing by 4? You multiply by 4. So if I go to my calculator and I take 0.0125 and I multiply it by 4, what do you get? I hope you got 0.05. So look, guys, if my rate, if my R is 0.05, I'm going to move that decimal 2 to the left, and my annual interest rate is 5%. Okay? Pretty easy there. Hopefully. Now, the last ones we have are very similar. Again, how did we derive this value? Well, wasn't it 1 plus r over 12? Yeah, see? Whatever this n value is here, it's the same here. So, we do the same thing. Subtract 1. So, r divided by 12 equals 0.0025. Then we multiply by 12 this time. So 0.0025 times 12 is 0.03. 3%. Okay? Hopefully that makes sense. C is the easiest one. Remember, isn't R just right here? Isn't this R 0.06? 6%. And the last one's pretty straightforward too. Remember, this was derived by 1 plus r over 1. So I subtract that 1, and r divided by 1 is r, so I'm literally left with 0.025. That's 2.5%. And that is it. That is how we do compound interest, whether it's a formula that's given, and we have to, or values that are given, and we have to write an equation and solve, or if they've given us the equation and we have to decipher what was what. That is what you have for your homework assignment tonight. So, this video is now approaching 31 minutes, so you have about 15 minutes to complete this assignment, and here is your assignment. I want you to do 1, 2, 3, 4, 5, 6, and 7. You actually don't have to do anything on the back. Front side only. Front side only. So that is your homework. Now remember, you have to obviously do A's and B's for these two problems. So the whole front side is your assignment. You got 15 minutes. Try to get what you can done, and whatever you don't is your homework. I hope you guys have a great weekend, and I will be back and see you on Monday.